2 of the arithmetic geometric.
So we are ready in our notes. We are skipping 9.2, so be sure as you're doing homework and review sheets and all that stuff, make sure you are skipping 9.2. All right, yeah, 9.2 you can't. All right, so we're ready actually on page 62 for problem number 3. All right, so we are on page 62, problem number 3, and it says, find the common difference, the 8th term, and the explicit rule for the nth term. Now, I want to give you, I can't remember if I gave you this formula already or not. Does that look familiar to you?
No.
Nope, all right, good. I'm glad I'm giving it to you. This is your formula for an arithmetic sequence. I'm going to go ahead and give you the one for a geometric sequence also. You do not have to memorize these. They will be given to you on the quiz, the quest, and the exam. So you're not responsible for memorizing them, but you do need to know which one goes with which. So this is your arithmetic, and this is your geometric. And these are the formulas that will allow you to look at a sequence like in 3A. I'm on page 62 of my notes, problem 3A. And it says, among other things, find the 8th term. Now, the 8th term, could you just keep on going here? Yeah, that wouldn't be bad. 8 terms, that would be okay. But what if it said find the 80th term? Oh, that would take a long time. Could you still do it? Yeah, but it would take a long time. So we have a formula that will find whatever term we want. And here's how it works. The 8th term, n is the number of terms. So if I say find the 8th term, it's a sub 8. If I say find the 80th term, it would be a sub 80. A sub 1 then, if a sub 8 is the 8th term, what's a sub 1? First term. That's your first term. So a sub 1 is 3, plus the common difference. D is the common difference. If you are arithmetic, that means you are getting from term to term by adding the same number. Remember, we talked about that last week. So, what am I adding here as I go from term to term? Paul? Negative 4. So this is negative 4 times n minus 1. Now, what did we say n was? That n is the same as this n. What did we say n was? 8. So this is going to be 8 minus 1, which is 7. So the 8th term is the first term minus 28, so it would be negative 25. The 8th term is negative 25. So problem 3A says find the difference. You did that. Paul said the difference is negative 4. Bingo. Find a sub 8. We did that right here. A sub 8 using our formula. Now, in general, what will a sub n be? Well, go back up to your formula. A sub 1 was 3. The common difference was 4 times n minus 1. So all I'm doing for this problem right here where it says find a sub n, all I'm doing is taking my formula, which will be given to you. You don't need to memorize it. Here it is. And I'm plugging in what I know as the first term and what I know as the common difference. Now I'm going to simplify that. So here I can distribute. What will this be? 3 what? Minus 4n plus 4. Now I'll combine like terms. And what's that equal when I combine like terms? 7 minus 4n. And that's called your explicit formula. Okay, let's try the next one. It's the same thing. Would you agree that this is arithmetic? The directions tell me it's arithmetic, but would you agree it's arithmetic? That means I'm getting from term to term by adding the same number. Am I adding the same number here? What is that number? Negative 0.5. So the common difference is negative 0.5. Right? Now, I need the 8th term. So come back up. This is the formula you're using. You're going to put 8 right here for n. So what's that going to look like? A sub 8 is going to equal what in this set of numbers? What's going to go here? What goes here? 10, first term. You said the common difference was negative 0.5, and then what will n minus 1 be? N is 8, so that's going to be 7, yep. So 10 minus, what is that, 3.5? So I think, if I did my arithmetic right, that is 6.5 for the 8th term. So let's do that next one. Same thing. We want to find D, A sub n. Oh, wait. I haven't done A sub n for that one yet. I have to find A sub n. This is back to problem B. The last part says find A sub n. N minus 1 in the formula. And n is 8. So it's 8 minus 1. Alright, so now I'm going to write my formula, and I'm not going to do anything except put in A sub 1 and D. So my A sub 1 is what? 10. A sub 1 is the first term. Plus, what's my D? Negative 0.5 n minus 1. So I'm not putting in any n's, I'm leaving them n's. Remember, this and this match. So if you're putting an n here, you're going to put an n there. If you're putting an 8 here, you're going to put an 8 there. So 10 minus 0.5n plus 0.5. What's that general formula? It's called an explicit formula. What is that explicit formula? Like my terms? 10.5 minus 0.5 n. All right, one more of those, then we're going to do the same thing with some geometrics. One more of these though. All right, so look at this sequence right here. This is C on page 62, C. All right, tell me, what's D? D is 6. Everybody got it? D is the number that it stands for common difference. It's the number that you add over and over and over again as you build the sequence. Got it, Mazzy? All right, now I need A sub 8. That formula. I'm clearly letting n be 8. So here we go. What's the first term? 10. What's the common difference? 6. What's n? 8. So that's 7. So what is that? 52? 42 plus 10? All right, now A sub n. Formula says I need my first term, which is 10, plus the common difference, which is 6, times n minus 1. A sub n. N. These are always going to match. So n and n. Alright, so I have 10 plus 6n minus 6. What's that formula going to be? 4 plus 6n. That's called your explicit formula, or explicit rule. Okay, we're skipping part 4, and we're going straight to page 63, part 5. This is exactly what we have been doing, except the sequences are geometric. What does that mean to be geometric? To get from term to term, we multiply by the same number. These guys we were adding, and we use that formula. Now we're going to use this formula. Everything stands for the same thing, except we have an R, and R stands for the common ratio. And the common ratio is the number that we are multiplying by to get from term to term. Okay? So we're multiplying by what here? 2. So my ratio is 2. All right, so what did they ask me for? They asked me for the ratio. And then they asked me for the first term. Anybody that misses this is blind. What's the first term? 3. Then they say, all right, what's the 10th term? Here's your formula. Clearly, we're letting n be 10, right? So what's that formula going to say? Start plugging stuff in. The 10th term is going to be what? 3 times the ratio, which you said was 2, raised to what power? What?
10 minus 1.
10 minus 1, which is the 9th power. 10 minus 1. You're finding a sub 10. N is 10. Your exponent then is 10 minus 1. 9. So that's going to be a big number. Geometrics are big. 3 times 2 raised to the 9th. Please do not ever, ever, ever try to combine these two. Do not combine. Ever. They have to be separate. 3 times 2 to the 9th. Okay, let's look at the next one. What's going on here? The questions you need to answer are what's the ratio, what's the first term, and what is the 10th term? Here we go. What's the first term? 8. What is the ratio? Can you tell? What are we multiplying by to get from term to term here? We're not timesing by 8. 1/8. We're multiplying by 1/8. 1 over 8? What?
I think you said n8. Oh, no.
1/8. I'm multiplying by 1/8. I don't know what I said. That's what I meant to say. I'm multiplying by 1/8. Alright? Now, what's the 10th term going to be? We're using that formula right there in the box, because that's my geometric formula. And this is geometric. I'm multiplying by an 8. So a sub 10 will be what, according to the formula? Come on, according to the formula. a sub 10 is going to be what? 8 times 1/8 to what power? The 9th. Why is it the 9th power? Because n is 10. And the exponent is n minus 1. So 10 minus 1 or 9. Alright, so this is going to be a small number. It is really small. 5.96 times 10 to the negative 8. Remember, you cannot combine the 8 and the 1/8. They have to stay separate. You put them in as separate numbers on your calculator. 8 times 1/8. Alright, one more of these. We want the ratio, the first term, and the 10th term. Alright, so here we go. Let's fill in the blanks. Luke, what's the ratio? So negative 6 times 2 is 18. Negative 6 times negative 2 is 18. Negative 3. So we're right with the negative. We need a negative. Negative 6 times negative 3 would give me 18. Times another negative 3 would give me negative 54, and so on. So my ratio is negative. Alright. Kian, what's a sub 1? Negative 6. So my formula tells me to find a sub 10, I'm going to take the first term times the common ratio to the 10 minus first power. And I got 118098 as my answer. Obviously, to get these big numbers, it really helps to have a calculator. All right. Now on the back side, we have some limits. So let's take a look at these limits, and then we'll do some review for our quiz tomorrow. All right, so here we go. All right, so we're going to find the limit of each sequence. Now here's how I want you to think about a limit. A limit of the sequence is you start listing the numbers, you're going on down the line, listing all the numbers. A limit is like a wall that the terms get closer to. As you keep moving along, they get closer and closer to that. An example would be B. B is a good example. Because if you looked at the number line, and here's -1, and here's 0, and here's 1. Here would be 1/3, right? There's the number 1/3 on the number line. And then here would be 1/9 on the number line. And then here would be 1/27 on the number line. These terms are marching along. What are they doing? They're getting smaller and smaller. Here's the wall at 0. Because will these terms ever become negative? They're just going to continue to get smaller and smaller and smaller. So for B, the limit as n approaches infinity of this sequence is 0. The answer to B is 0. Because the terms, if you kept going in the pattern, would just keep getting smaller and smaller and smaller. But they're never going to go past 0. You're never going to have any negative ones. They're just going to get all squished up in that space. Now, what happens with A? Yeah, A doesn't do that. A doesn't have a wall. A just keeps on going. So for A, we would say no limit. And the mathematical word for that is divergent. Now, I don't care if you use the mathematical word or if you write no limit. There's no limit. These terms just keep getting bigger and bigger and bigger and bigger. All right, what about C? Think about, what would the next term be? Well, it would be positive, what? 64, positive 64. And then the next one would be negative 128. Wait a minute, what's happening? Some of them are positive and some of them are negative, but what's happening? They're going farther and farther out, aren't they? Both directions. So C also has no limit. Now, for the next set, D, E, F, G, and H. D, E, F, G, and H are all the same kind of problem, and we have done this before. Back when we were graphing horizontal asymptotes, do you remember when we had to graph things like 2x plus 1 over x? And I said, where's the horizontal asymptote? And you did this, and you said the horizontal asymptote is at 2, because it was 2x over x. That's a limit. That's exactly how you do these problems. So what's the limit for D? Look what you have. You have an n over n plus 1. What's the limit? 1, because it's n over n. So the limit is 1 for E, or for D. Now what about for E? What's the limit? 2/3. Remember, you're just comparing the highest powers. You're comparing the n's. What about F? Compare the highest powers. What do we have in F? 4/5. Because it's 4n squared over 5n squared. No confusion. It's 4n squared over 5n squared. Now G is different. What's going on with G? There's an n squared on the bottom. We have a 5n squared on the bottom. Do we have any n squareds on the top? So we think of that as 0 n squareds on the top. What's 0 over 5? 0. So the answer to G is 0. If a power is missing, like I didn't have an n squared on the top, then put 1 on the top. 0 n squared on the top. Likewise for H. What's the highest power in H? N squared. I have 8 of them on the top. How many n squareds do I have on the bottom? None. So I go ahead and put 0 on the bottom. What's 8 over 0? It's not 0. It's undefined. There is no limit. You cannot sit on the egg. You cannot have a 0 in the bottom. Ever. No limit. So these problems should be a cinch for you. Number 1, we did them before. And number 2, they're just easy. If the powers match, if you have an n and an n, then whatever the ratio is, that's it. If they don't match, put a 0 in where 1's missing. If the 0 goes on top, then the answer is 0. If the 0 goes in on the bottom, then the answer is no answer. Now the other kind, so that was D through H. Now the rest of those are built differently. They don't look the same. They're a different kind of problem. Don't let the limit notation confuse you. We have this problem, and then we have this problem. Do not let the exponents interfere with your thought process. Okay? Ichi? Ethan? Do not let the exponents bother you. What you're really looking at is this number right here. That's the number that matters. If you have a calculator, would you just start multiplying 2/3 times 2/3 times 2/3? Just keep multiplying 2/3 more and more times, and tell me what happens. What is happening to the number as you keep multiplying by 2/3? It's getting smaller. It's getting smaller. So the limit is 0. It just keeps getting smaller. Now, multiply 5/4 times 5/4 times 5/4 times 5/4 as many times as you can. What's happening to that? It's getting bigger. This one has no limit. Now, what's going on then? What's the rule? If this number, this is the only important number in the problem, nothing else matters. If that number is less than 1, then your terms are going to get smaller and smaller and smaller, and the limit will be 0. If that number is bigger than 1, then your terms are going to get bigger and bigger and bigger, and there won't be a limit. They just keep getting bigger, diverging off into space. So, what do you think about K? What's the answer to K? No limit, because 1.5 is bigger than 1. These guys, you either have a limit of 0 or you have no limit at all. All right, that's it. Those are your options. It's 0 or it's no limit. And what makes the difference? Is that number bigger than 1 or less than 1? Less than 1, limit 0. Bigger than 1, no limit. So what about, what is that, L? What about L? 0, because 0.8 is less than 1. Okay, 0.8 is less than 1. All right. Okay, so we're going to do sums tomorrow after our quiz. So what we want to do now is just touch base quickly on the kinds of problems. We're going to have 4 problems on tomorrow's quiz. And I would like you to get out your practice quest. Remember, we're not even going to have a quest over this, but we're doing these as practice problems. You have an optional quest. But turn to practice quest, or practice test 2. Practice test 2. And the problems we need to do are number 10. All right, so we're on practice test 2 for 9.1, 9.3. If I do, they're over there. Handed them out a long time ago. Whatever. Okay, they're over there somewhere. 9.1 to 9.3, practice test 2, and we're looking at problem number 10. All right, so here we go. Read the problem, and then decide what your strategy is going to be. What do you think your strategy is going to be for problem 10? Paul? The tree diagram. Yep. Because what's going on in this problem are 2 things. What's the deal in the problem? What's happening? What are the 2 things? Popcorn and soda. Now, Mrs. Ford has told you repeatedly, you gotta decide, popcorn or soda. What's going here, what's going here? So, how do we tell? Read the question. Find the probability that they will serve soda. Okay, so this is soda, no soda. Soda, no soda. That automatically means that this is popcorn and no popcorn. The two things in the problem are popcorn and soda. You either have it or you don't. The question is, tell me the probability of soda, so that's your bottom row. That's your bottom row every time. All right, so here we go. Let's start filling in numbers. If the cafeteria serves, well, wait a minute. What's the probability of popcorn? It's in the last sentence. They serve popcorn twice a week. What does that mean? This is the school cafeteria. 2/5. So the popcorn is 0.4, no popcorn is 0.6. Let's talk about that one more time. It says we serve popcorn twice a week. That's 2 out of 5 days. You can put 2/5 here. If you like to do it with fractions, you can put 2/5 here. I changed it to a decimal. 2 divided by 5 is 0.4. Serving 2 out of 5 days means 2 out of the 5 days I go to the cafeteria, there'll be popcorn. So the probability is 2/5. Then the probability of no popcorn is 3/5 or 0.6. Now, if we serve popcorn, there's a 90% chance I'll have soda, which means there's a 10% chance I won't, right? If I don't serve popcorn, no popcorn, there's a 45% chance I'll serve soda and a 55% chance I won't. All right, who remembers what we need to do? We want the probability of serving soda. So we want this probability right here. We want soda. So we multiply popcorn and soda. So that would be 0.36. Right there. Popcorn and soda is 0.36. But also, we could have an additional probability, which is 0.6 times 0.45, 0.27. So what is the total probability of sodas? You could get it this way, or you could get it this way. What's the total probability? 0.63? Everybody good with that? All right, number 11. There are 60 students on the bus. 40 of them want to teach, 35 of them want to nurse. Assuming that every student on the bus expressed an interest in one of the careers, how many indicated an interest in only nursing? What's your thought on that one? Venn diagram. And in your Venn diagram, you have a ball for teaching and a ball for nursing. It says there's 60 kids all together. That's the bus right there. There's 60 kids all together. 40 of them like teaching and 35 of them like nursing. That equals 75, which is problematic because there's only 60 kids on the bus. What does that mean? There's overlap, right? Think about it. Raise your hand if you want to be a teacher. 40 hands go up. Raise your hand if you want to be a nurse. 35 hands go up. That's 75 hands. There's only 60 kids. What happened? Some kids raise their hands twice. How many? 15. So there's 15 kids here in the middle. They raise their hands twice. right? Now, the entire T-ball was 40, but 15 of them have already been counted. So what's this? 25. The entire end ball was 35. This must be 20. So now I can answer the question. How many indicated an interest in only nursing? These guys right here. Only nursing were those 20. All right, now we're down to 15, problem 15. Remember, this is a very specific quiz, has 4 problems. We've already done 2 of them. Here come the other 2. 15. This is another Venn diagram. It's drawn for you. And you are told this information. All right, so here we go. Here we go. How do I start? What happens here? What do I need to do? What does this mean? A and B. Wouldn't that be the football? So in the football goes 0.55. Now what does this mean? The entire A circle, the whole circle is 0.65. So how much is this? 0.10. The whole circle is right here. You've already marked pi 5. So you've only got 10 left. The whole circle is 0.8. So this has got to be 0.25. Now add those up for me. What is that all added up? 0.9? Wait a minute. What are they supposed to add up to? 100. What does that mean? Somebody's not in the ball. There's 10 of them out here that aren't counted. They're not an A or a B. All right, so now we got the picture drawn and we're going to answer those 2 questions. All right, what's that top question say? Not in A and in B. So you gotta be in B, but you can't be in A. So what is that? That's 0.25. So the answer is 0.25. You can't answer the question until you've drawn the picture. So be sure you fill in the picture first. Once you fill in the picture, it's easy. You're in B, but not in A. What's that second one say? Not in A and not in B. Isn't this you? 0.10. And then the last one is number 16, which is the next page. It's got the charts and everything. This is the last problem on the quiz. Well, I mean, there were 4 problems. This is the 4th one we talked about. I don't remember what order they're in. All right, so here we go. We're going to pick a kid out of class 1 and a kid out of class 2. All right? What is the probability that neither likes science? All right, so look at class 1. What's the probability a kid won't like science? 0.9. And times a kid won't like science in class 2. 0.8. So the answer is 0.72. What is the probability of the first liking English? Okay, first likes English. That would be 0.2. And the second likes math. 0.4. 0.08. What is the probability that both will like English? All right, so number 1 likes English, 0.2. Number 2 likes English, 0.3. That's 0.06. what is the probability that one will like math and the other will like art? This is the tricky one because it's actually two questions. It could be math and art, or it could be art and math. Do you understand what I'm saying?
Yeah.
So you gotta do both of them and then add them together. So let's do math, art. So first math and second art. So that would be 0.06. Or first art and second math. That would be 0.04. So the answer to the question is add them together, 0.10. And that is your quiz tomorrow, those 4 kinds of problems. Okay? It will help to have a calculator tomorrow. It wouldn't be an absolute 100% necessity, but it would help to have one.